Okay, let's have a look at what we've got here. We've got our low power FPGA board there. We've got our little USB UART here that's pretending to be the cellular modem so that I can send commands in to inject. I've got the oscilloscope probe on pin B6, so that is, should we come over here for a minute? This is a nice moment to have a look. If we run the config command, we can see that pin B6 is our primary circuit, which will control the LED on the board, the LCD panel, and the main FPGA. Now, they're not connected, but we can see that it switches it by seeing that the LED goes, or actually probing the pin, which is what we're doing with the oscilloscope. And we can see at the moment, so that's on our blue channel, which is channel 1, that the power is currently off. So if we come back over to here, and we say plus LCD, so we saw that LCD is in the circuit 0 description, so we don't need to put the 0 in. For the ID, we can do it by name, which is fine. So I can do that, and I'll hit enter on that, and we can now see that that has gone, that channel 1 on the oscilloscope has gone high. And so if I come back here and we say minus LCD, pan back out so that we can kind of see it all happening in one shot. We can see that it's gone low, cursor up, and we'll do plus. It's gone high. So we're seeing it switch the power in real time when we do the command, which is kind of nice. So let's turn it back off. Now this is where it gets a little bit fun. So this is talking to that other UART interface. So I can, on my keyboard, pretend to be the modem making a phone call. So if I start typing R-I-N, and I won't press G just yet, because when I press G, we should actually see the power go on, because the low power FPGA has detected that the modem needs to do something. And so it sent an event, and then the software on the phone would be using the library behind this to do not config. We want status. Oops, turn caps lock off. I had it on for typing ring. And that's right, because it takes 2 rings for it to report, which is fine. By the time the FPGA has turned on, the second ring has occurred. Now it says there's a cellular event there, and we go cell play. Oops, and again, capitals. RR, ring, ring. So we know that it's rung. And if we wander back over here, and if I do a plus Q I N D, typing this one-handed, let's hope I haven't got it wrong, and then say hello. So this would be if we had a Q indicate command from the modem. And look, we have it there. We have the RR for the ring, and we then have the Q to say there was a Q indicate, and hello. So you get a whole line for each Q, and you just get a single character for the R. So it's super easy to parse as well. And so if we turn the power off again, and if I do, again, I'm going to type a, where are we? Plus Q I N, and when I press the D, the power goes on. So as soon as the Q in has happened, it's powering up the main FPGA. So yeah, do a final status, but again, lowercase. We can see that it says that the power is on to circuit 0 and the cellular event is logged. Let's just, as a final thing, clear out the cellular event log. Do status now. It says no log, events logged. and the log is empty. So we've got all the functionality that we need for this to be monitoring the modem and for us to be able to control the power to all the subsystems. So this main FPGA can stay off, and that little tiny FPGA that uses practically no power, particularly once you move it off of that USB board onto a dedicated module, then its power usage will be like a milliwatt or something, because it's super tiny. So that's it. We've got it all working. Thanks, and yeah, we'll hopefully see this integrated into the MEGAphone prototype quite soon.